Hey everyone, good morning. Today we are going to do a small algorithm. So it is going to be about popping an item from list, at the nth place, so from a linked list. So let's just write the code. So I'm in the linked list directory, and as you know, we don't have anything in here. We don't have that function in here. So I'm just going to create the function. So I'm going to write code followed by ll pop at nth place, right? .py. And let's go ahead and define our nodes. Okay, so let's go ahead and define our node. So let me just define the init function, and as you know, we take some data. So self.data equals to data, and by default the next is going to be none. So in the same way, we are going to create the linked list class. So I'm just going to do the basic one. So def init. I'm not going to give anything here, so I'm just going to set the default head to be none, and maybe just define an append method, append, which takes new data, and let's just assign this to a new node. So new node equals to node of data, right? Sorry, node of new data, my bad. Now we just have to add it. So this is a default append method that we have covered multiple times, so you can watch the previous videos in order to find out how the append method works. So let's write the append method again. So if self.head is none, right, or I can just assign it to some value, I guess. No, I think it will be better. Head is none. If it is empty, then self.head is new node. Okay, else what we'll do is I'll take cur node is equals to our head and so while the next is not empty, so it is not equals to none, we'll just iterate through the entire linked list. Okay, so after this is done, I'll just set cur node dot next is equals to our new node. So that takes care of the append, and we might want to print the list in order to see what's inside. So let's write print list. So I'll just set temp equals to our head, and I'll just print that temp. So followed by, I guess I can just print temp, honestly. And the end could be, I don't know, something like this, I guess. And after we are done with the we have to iterate through it. So temp equals to temp dot next, and after we are done, I'll just print an empty line. Okay, so that takes care of the print list. Now let's focus on our main function, which is our popping at nth place. So this is a question that you generally see in a lot of linked list interviews. So Adobe asks this question, so as like Morgan Stanley and even AWS, Amazon, like everybody asks this question. So it has been asked in the previous interviews. So let's do the pop at nth place. So def pop at nth place, and we'll take the n. So the idea is simple. There are a couple of ways to do it. One way is to use an array, but that will increase the size. So using array, it's like really simple. Just iterate through the list, add it to an array, and then pop out that element from that place. The only problem being that if we do that, imagine if there are a million nodes, we would still have to allocate memory for a contiguous memory for a million nodes array list. Since we don't want to do that, since we want to write an efficient code, what we are going to do is we are going to use a technique. I don't know what this technique is called, but basically the idea is to create another node that is n places behind our current node. Right, so let me explain what I mean. So let's take our current node. Imagine, so this is our head, and let's call our another node. We can call it slower node, or we can call it back node, whatever. So let me just call it temp node for now. So temp node is by default would be none, and we'll set a count value which is equals to 0. Right now, so while current node, now while this is not equals to null, what we will do is we'll pass to the current node. So current node equals to current node dot next, and we'll increase the count. So since we added the current node as well as increase the count, now the idea is that I want to initialize this temp node after we cross n places in the list. So imagine this is our list, right, and maybe n equals to 2. So basically I want to pop this element, right? So what I'll do is I'll set our current node. Now initially when it is equals to 1, I'm not going to initialize our temp node. Okay, so the temp node is still going to be empty, or none. Now when the current node is in the second place, I won't initialize then as well, because I want it to have the space of 2 elements between our node and the current node. But when temp node becomes, okay, so when current node becomes 3, the temp node should be initialized to the head, so which is 1 in this scenario. So that's the idea. So I'm going to write code according to that. So I'll just write while, sorry, not while, if count is greater than or equals to n, only then we have to check initially if the temp node is none. So if temp node is none, let's initialize it. So temp node equals to self dot head, else we'll just iterate the temp node too. Perfect, and that should take care of our entire problem. And after, so what happens right now is now since it is a 3, this will become 1, right? So let's follow the procedure. So now when it is at 4, we get 2. It's at 5, so this will become 3, and at 6 this will become 4, right, and at 7 this will become 5, and that's exactly what we want. So when I say 2 places from here, I want this element, right? Or sorry, we want this element. So what we do is basically it moves to the next iteration as well, because while temp, so if it is 7, so this is 5, this should be fine. So let's just write the program, and if we want we will make some minor changes, but yeah. Count greater than or equal to n, temp node, and this should be done. So let's just return the count here, and let's, sorry, not count, let's return our temp node here, and that should be done. So let's just run the program. So I'll create a linked list, and I'll append the values. Alright, So we have 2, 3, 4, 5, 6, and 7, and let's print alright, linked list dot pop at nth place followed by our value, which is 2, right? So when I run this program, oh yeah, we have to pop the data, sorry, not the node. There you go, we get 6, and that's exactly what we want. Alright, so this covers our entire problem. So 3, 4, 5, 6, 7. So, oh yeah, before checking it goes to the next node, because when it is 7 we are doing the next node. So at the when current node equals to none, temp node becomes 6, and that is exactly what we want. So this is a pretty simple problem, popping at nth place, and it's, and this kind of technique is actually used in other scenarios too. So for instance, let's say if you want to define a function, like maybe I'll ask you pop middle of the list, or find cyclic linked list, or pop at any place. So any of these questions, we can use this strategy, whereas where we create a slower node as well as a faster node, and depending upon the n we are given, we will write we will initialize it after our count crosses n. And I think that's about it. Thank you.